This is question 6 of section 1 of Natural Sciences Admissions Assessment, past paper 2017. And this is a question about inequalities, which has been disguised as a question about sequences. So in this question, we have two sequences, and we've been given the nth term of the two sequences. They're 7n plus 1 and 99 minus n squared. And we want to find the smallest value of n for which the nth term of s is greater than the nth term of t. Now, we can rephrase this question to make it seem a lot simpler. So we just want the smallest n for which 7n plus 1 is greater than 99 minus n squared. So actually, it's really got nothing to do with the sequences. We just need to solve this inequality. So why don't you have a go at solving this inequality now? I would recommend keeping the inequality sign the same way around the whole way through, because it just makes things a lot less confusing and you're less likely to make errors. Okay, so the first step is going to be to rearrange to get 0 on one side, as follows. And now we want to factorise this. And if you're struggling to factorise the 98, you could just look at some of the answers up here, because one of these is going to be linked to whatever you need to have in your brackets. So that could be a way of doing it, or just think it through and work out what you need to multiply to get minus 98 and what you need to add to get 7. Notice that 98 is 7 times 14, and this works perfectly because it has a difference of 7. So we get factorised like this. So we get n is minus 14 or n is 7. So now we have two possible values for n. So these are minus 14 and 7. We can immediately rule out the minus 14 because it's negative, and we know n can't be negative in this context. So now let's consider the 7. Now, we solved this inequality as if it was an equality, so we got a quadratic in n as such. And so if we plug 7 in to this, we would get 0, which means that when n is equal to 7, these two things are equal. But notice we want a strict inequality. And so 7, when n is 7, that's not good enough, because it's not going to be strictly greater than, it's going to be equal to. So the smallest n for which it is strictly greater than must be 8. So our answer is C.